Chapter 7 AP Environmental Science. Going to talk about climate, a little bit about weather, and biodiversity, including things like... Anyway, little case study to start things out. We, of course, live in a temperate deciduous forest, so the pictures to the right should look familiar. The reason it's called temperate deciduous forest, temperate because we get a wide range of temperatures. If you think about it, 90 in the summer, all the way down to like minus 20 in the winter. Deciduous because our trees lose their leaves, which is actually a strategy to keep them alive. Otherwise, what would happen is with the increased surface area of a leaf compared to a needle, they would actually lose water during the winter time. So why do forests grow in some areas and not others? Kind of a little focal point on the second lecture of this chapter, but climate is going to drive all of this. We've got tropical regions, of course, which are around the equatorial regions. We've got polar regions, which is the North Pole and the South Pole. And, of course, we've got temperate in between, and there's some other variables that come into play with this. But these create different things called biomes. A temperate deciduous forest is globally more distributed than any other ecosystem. In the United States, it ranges all the way from Maine over to kind of where we are, all the way down to Florida. So that's a very expansive part of the United States. All right, weather versus climate. First of all, weather. Weather is a daily occurrence. It's hours, it's days. Of course, the old saying, if you don't like where you live, particularly in our region, just wait a few hours because it's going to change. It's because our climate, or our weather rather, can change very quickly. Weather technically is temperature, precipitation, wind speed, cloud cover. It can last from hours up to days. So a storm to the right, that would be classified as a weather pattern. Climate is actually an area's general pattern of atmospheric conditions over decades and longer. So what we're going to look at in this unit are something called climatograms. Climatograms are actually going to show us those two factors, precipitation and temperature. A big factor that also drives climate are ocean currents. If you take a look at a classical example of keeping an area warm, we look near the equatorial region where the sun is very direct. What happens is we get this conveyor belt system of ocean currents going up, and it keeps England and that region artificially warm compared to other places in that latitude. So if you see the latitude of England is way up here, we're way down here. What happens is because of that, they are significantly warmer than us and really don't experience the snow that we do here. So ocean currents are driven by the prevailing winds, the Earth's rotation, redistribution of heat from the sun. That is, and I'll show you a slide on that in a second, but at the equatorial region, it is the most direct sunlight constantly, and surface temperatures and deep currents that actually help drive all of this. There are many factors that drive our wind or our air circulation patterns across our planet. Three of them that are listed. First one is the uneven heating of the Earth's surface. So if you look at this picture, the equatorial region, of course, year-round gets the majority of the sun. And then what happens is we get convection currents, and it's kind of based on the ideas of physics. So what happens is we get warm air hitting the equatorial region. That warm air rises. As the Earth turns, it goes north in this case, cools, and actually descends and creates a convection current with the warm air displacing the cold. That is actually called a Hadley cell, and we also have Hadley cells here, generally between 0 and 30 degrees north, 0 and 30 degrees south. Then what happens is we get that warm convection current here, and it is going to rotate. And again, it's going to rise up, it's going to cool, and it's going to come back down. Those are called Ferrel cells. Ferrel cells are about 30 to 60 degrees north and south. Same thing in this region right here, so above 60 degrees north and 60 degrees south are called the polar cells. Again, due to the uneven heating of the Earth, we have Hadley, Ferrel, and polar cells. The rotation of the Earth, of course, on its axis is also going to drive this as it's spinning. And properties of air, water, and land. So if you think about the region where we live, we actually get affected by Lake Michigan a lot because what happens in the summertime is we've got cool air, and that cool air is going to blow into Milwaukee and actually cool us down. The opposite's going to happen in the wintertime where the water, because of its high specific heat, stays warm, and it's going to blow onto land and actually keep it a little artificially warmer on the east side. Here's just another way of looking at it. What happens, as you know, with the laws of physics is hot air is going to rise. As it rises, eventually it's going to form precipitation because it condenses. Then what's going to happen is it's going to cool, and that cool air is going to come back down to the earth. What happens is as it cools, we get dry air, and that's associated with warm, dry air. Now that's actually going to drive different biomes that we'll take a look at in the second part of this chapter. So once again, we get hot, moist air like in the equatorial regions rising up. As it rises up, it cools, it condenses. That's why they have so much precipitation in the jungles. Then what happens is it is dry, it is cool, and it will descend onto the earth. Also, of course, are the ocean currents, and this does a really good job of showing our ocean currents. Aside from the air, the convection currents driving some of these ocean currents, we also have a couple variables that come into play. We have different salinity in the oceans. So down here you can see we have very high salinity as compared to the northern region, and that is going to cause convection currents due to displacement. And then we've also got cold water here, and we've got warm water here. So that warm water is going to travel down and displace the cold water, and we're going to get these unique patterns that flow and actually create huge ocean currents. These, of course, were used a lot by sailors back in the day. They would actually, if they left from England, they would have to come down here and land kind of in Florida in order to catch those, and particularly in things called the trade winds. One thing that really has a big effect on our climate, something we'll talk about a lot more in class, is something called El Nino. The opposite of El Nino is La Nina. It's called the El Nino Southern Oscillation. It occurs every few years. There's really no rhyme or reason why it occurs. But what happens is in normal conditions off the coast of Ecuador, Ecuador is in South America, normally we get air currents that travel this way and conditions are normal. Then what happens, for whatever reason, those air currents actually reverse, and what happens is it can actually suppress something called upwelling. Again, we'll get into detail more in class, and it can affect much of the Earth's weather for up to 1 to 2 years. In the region we live, our summers tend to, or our winters rather, tend to be much warmer, and we get a lot more snow here, so it's kind of beneficial to us. Again, we'll expand on that. What keeps our planet warm are greenhouse gases. It's a beautiful thing because otherwise our planet would be cold all the time. The main greenhouse gases you need to know, actually the most prominent, is actually water vapor. If you think about hot, humid days in the summertime here, a lot of that is, a lot of the reason it's warm is because that water holds heat. And what happens is that as it holds heat, it gets warmer and warmer and warmer. CO2 is another greenhouse gas. That one's going to come back later in the year when we talk about climate change. Methane is a big one, and nitrous oxide. So make sure you know those greenhouse gases. We do have a natural greenhouse effect, which keeps our Earth habitable. Otherwise, we would be cold. What essentially happens is the sun's rays come to the Earth absorbs it, the energy, and actually will re-release it. Then what happens is these gases hold that temperature. Other things that can actually affect our climate is actually mountains. If you think about a city like Los Angeles being in this region right here, and then we have the Sierra Nevada mountains, we get something called a rain shadow effect. So what happens is prevailing winds come in, and they're not quite strong enough to get over the mountains with moisture. So what happens is as the clouds go up and up and up, they're warm, they actually condense when they get cooler, and what happens is precipitation falls here. That is called the windward side of the mountain range. The opposite side, like where Palm Springs is in California, is called the leeward side, so it's dry. So once again, the prevailing winds, the clouds cannot get up and over the mountains, so they need to drop their precipitation. That's the windward side, and then the leeward side. This can actually create little microclimates. Biomes are something that's going to be the focus of the rest of the chapter. Biomes are large land regions with certain types of climate and predominant plant life. They're not uniform, they're not consistent always. They tend to be mosaic patches here and there that exist, and they tend to occur in different regions, different latitudes, but there are exceptions again because of things like mountains. Temperate deciduous tend to be in the middle latitudes. Where we live, it's about 45 degrees north latitude. That's a mid-latitude. We then, what happens is as we get north into Canada, we get things called boreal forests or taigas. And then as we get toward the equatorial regions, of course, we tend to get tropical rainforests. We'll break that down later. And finally, of course, you can see a little picture here that represents this. One thing is, as we get near the equatorial region again, we get tropical forests. As we get away, we tend to get deciduous forest, coniferous forest, tundra, and then eventually polar and ice like in the North Pole. And of course, that happens in the opposite effect in the southern hemisphere. Another huge variable people don't usually think about are mountains. What happens in mountains is as we go up a mountain climate, it tends to follow the same pattern that I just took you through. That's it for the first lecture.